What if you could look back, not just hundreds or thousands, but billions of years into the past?
What if you could witness the birth of the very first galaxies and hear the story behind the most powerful telescope ever built by humankind? This is not science fiction. This is NASA's Cosmic Dawn. Welcome to a journey that began with an idea and reached the edge of the universe.
The sun, just like the stars we see at night, is a star. It's a giant ball of super hot hydrogen. Gravity squeezes it in and it creates energy, which is what makes the sun shine. Eventually, it will use up all of that hydrogen, but in the process, it's creating helium. So it will then use the helium, and it will continue to use larger and larger elements until it can't do this anymore. And when that happens, it will start to expand into a red giant about the size of the inner planets. Then it will shrink back down into a very strange star called a white dwarf. Super hot, but not very bright, and about the size of the Earth. But our sun has a pretty long lifetime. It's halfway through its 10 billion year lifetime. So the sun will never really burn out, but it will change and be a very, very different, dim kind of star when it reaches the end of its normal life.
What is a black hole? Well, the name is actually a little misleading because black holes aren't actually holes. They're regions in space that have a gravitational pull that is so strong that nothing can escape, not even light. Scientists know about two different sizes of black holes: stellar mass black holes and supermassive black holes. A stellar mass black hole is born when a massive star dies. That's a star that's larger than our own sun. These stars burn up all the nuclear fuel in their cores, and this causes them to collapse under their own gravity. This collapse causes an explosion that we call a supernova. The entire mass of the star is collapsing down into a tiny point, and the area of the black hole is just a few kilometers across. Supermassive black holes can have a mass of millions to tens of billions of stars. Scientists believe that every galaxy in the universe contains a supermassive black hole. That's up to 1 trillion galaxies in the universe. But we don't know how these supermassive black holes form, and this is an area of active research. What we do know is that supermassive black holes are playing a really important part in the formation and evolution of galaxies and into our understanding of our place in the universe.
Great question. In fact, 2,000 or 3,000 years ago, ancient people on this planet that did great things figured out that the Earth was round. It was a sphere. This was a magical revelation for the Greeks and the Egyptians, who were able to see from the motions of the stars and the way the sun moved. They saw the way the sun's shadow worked in different places. And they figured, well, that's only possible if the Earth is round. And they took that information and it extended into the time of the great mariners that explored our Earth by ships. They made the first orbit of Earth by sea, and they knew the Earth was round, allowing them to go across one ocean and come back home the other way. If the Earth were flat, they would have sailed off the end. And so we knew that. But then, at the dawn of the space age, in the late 50s and 60s, we were able to see for ourselves that our beautiful home is a gorgeous round object known as a sphere. And that was really special. It put ourselves into context of our solar system and our universe. We have a big round sun and a beautiful round Earth and a round Mars. And today, we use the roundness of Earth, the spherical Earth, to use methods in space geodesy to figure out where we are, where we're going. I haven't been lost in years. That's pretty good. What's happening to the Earth, what's happening to our oceans as we take the pulse of our planet, and consider other worlds beyond as we explore those. So as we get ready to go back to the moon with women and men and explore other worlds, the roundness of our solar system and our universe is a special thing. And we should embrace that as we understand why our planet isn't flat.
You need to be in the right place at the right time. Auroras are the result of charged particles and magnetism from the sun, called space weather, dancing with the Earth's magnetic field, and they happen far above the clouds. So you need clear skies, good space weather at your latitude, and the higher, more polar you can be, the better. You need a lot of patience, and some luck is always helpful. A smartphone can also really help confirm whether you saw a little bit of kind of dim aurora because cameras are more sensitive than our eyes. The best months to see aurora statistically are March and September. The best times to be looking are around midnight, but sometimes when the sun is super active, it can happen anytime from sunset to sunrise. You can also increase your chances by learning more about space weather data, and a great place to do that is at the NOAA Space Weather Prediction Center. You can also check out my project, aurorasaurus.org, where we have free alerts that are based on your location, and we offer information about how to interpret the data. And you can also report and tell us if you were able to see aurora or not, and that helps others. One last tip is finding a safe dark sky viewing location with a great view of the northern horizon that's near you.
The important thing to understand about this question is that it's not an analogy, it's literally true. The elements in our bodies, the elements that make up our bones, the trees we see outside, the other planets in the solar system, other stars in the galaxy, these were all part of stars that existed well before our sun and earth and solar system were even formed. The universe existed for billions of years before we did. And all of these elements that you see on a periodic table, you see carbon and oxygen and silicon and iron, the common elements throughout the universe, were all put there by previous generations of stars that either blew off winds like the sun blows off a solar wind, or exploded in supernova explosions and thrust their elements throughout the universe. These are the same things that we can trace with modern telescopes like the Hubble telescope and the James Webb Space Telescope, the Chandra X-ray Observatory. These are all elements that we can map out in the universe with these observatories and trace back to the same things that form us. And the elemental abundances that we see in stars now are the same things that we see in the Earth's crust, we see in asteroids. And so we know that these are the same elements that were once part of these stars. So the question of how are we made of star stuff, in the words of Carl Sagan, the cosmos is within us. We are made of star stuff. We are a way for the universe to know
From a
itself.
spark of imagination to a telescope that sees the invisible, we are not just observing the stars, we're discovering our own origins. If this journey inspired you, don't forget to like, share, and subscribe for more, because the universe is vast, and we've only just begun exploring.